Hi, I'm Erin Glass, and today I'm joined by Adrian Mouat, who is on the DevRel team here at Chainguard. And today we're going to get smart in 5 minutes with Adrian. How are you doing today, Adrian?
I'm good, very happy to be here.
Yay, okay. Well, today we are going to dive into the world of vulnerability scanners and ask, what is a false positive?
Negative.
Yes. Okay, let's get right into it. What's a false negative?
So vulnerability scanners scan container images and produce a report of all the vulnerabilities they find in an image. A false negative is where the scanners fail to pick up a vulnerability that is present in the image. And that's as opposed to a false positive, which is where a vulnerability scanner says something is present in the image, that the vulnerability is there, but in reality it isn't.
So it sounds like you don't want either of them.
No, that's very true. I mean, ideally you'd have a perfect report that had no false negatives and no false positives, but that's hard.
Okay, thank you. So what's wrong with false negatives? Can they cause issues?
Yeah, definitely. So a false negative represents a vulnerability that is present in your image, but you don't know about it. And sometimes vulnerabilities, the vast majority are probably harmless and hard to exploit, but in some cases they can be absolutely devastating. And if we look at vulnerabilities like Log4Shell, that allowed remote code execution, which is basically game over in security terms.
So why do false negatives happen?
To answer that question, we first need to understand how scanners work. So what happens to begin with in a scanner is they build up a database of vulnerabilities. And to do that, they collate various data sources. So things like the National Vulnerability Database, and also reports put together by the Linux distributions, which explain the vulnerabilities that are present or not present in their own packages. And once they've collated all those sources, then we can move on to the next step.
So how many vulnerabilities are we talking? Like 10, 12, 20?
Oh, I guess there's millions of vulnerabilities, or tens of thousands at least, in those databases.
So what happens once the scanner has all this information? What do you do?
So once we've collated the database, we then need to take the container image that we're scanning and try and find an inventory of all the software inside that image. And once you have that, you can compare the inventory of the software against the database we created earlier and figure out which vulnerabilities are present.
So tell me more.
So a false negative will typically occur because the scanner has failed to identify all the software packages in the container image. And this often happens because software has been installed outside the package manager. So for example, I might have a Docker file that copies a file in from the environment, or downloads a file from the internet, or perhaps it builds some software. And sometimes the scanners won't pick up those files. And if they don't pick up the file, there may be a vulnerability in it that they're unaware of. And you compare that to a false positive. A false positive is typically a mismatch at a database level. So for example, the scanner's database may wrongly flag a container as having a vulnerability because there's a vulnerability that affects Windows, but it's also matching this Linux package by mistake.
So it sounds like false negatives present a lot of risk. What can we do to reduce them?
Honestly, there isn't that much you can do. I would recommend trying multiple scanners and seeing if they give you different results. Hopefully in the future, we will have better answers and our tooling will improve. One thing that we're working on is SBOM. So SBOM is a software bill of materials, and that's effectively the same thing as a scanner builds when it's looking at your image and trying to figure out all the software that's inside it. But we can also build our own SBOMs when we build an image. And if you have an SBOM that correctly identifies all the software in your image, then you've got a much better chance of getting a good correlation between that and the vulnerability database.
Interesting. Do SBOMs ever miss crucial information within packages or images?
They absolutely can do. It depends on how well your SBOM is created. So at Chainguard, we create our SBOMs at build time, and they have a complete understanding of all the software in the image.
Sounds great. Well, thanks so much, Adrian. Before you go, I have one last question for you. I heard that your #1 favorite aquatic animal is the rock hopper penguin. Do you have a second favorite aquatic animal you'd care to share?
Actually, I do. So there's the bowhead whale, and that's the animal that O'Reilly put in the front of my book. So that's why it's my second favorite.
Oh, that is beautiful. Well, thanks again, Adrian. And there you have it. We all got smart in 5 minutes. See you next time.